In today's lesson, we are going to write an equation in slope-intercept form again, but this time we're going to write it with a line parallel to a given line that passes through a given point. So we're going to be given an equation, and we're going to have to use a part of that equation to write the other line. So let's take a look at this concept of parallel lines. So a key word is parallel here. And so I think the best way to figure out this concept is to graph two lines. So remember, this is our y-intercept. So we're going to start by graphing that y-intercept. So we go down 2 spaces, 1, 2, put a dot there, and then we use the slope. And so on one of your problems tonight, you're going to just have to graph a line given the slope and the y-intercept. This is how we do it. Start with the y-intercept. We use the slope. Remember, the slope here, 2, tells me to go up 2 and right 1. So from this point, I'm going to end up going up 2 spaces. So that's from this point, 1, 2 spaces over 1. Up 2 over 1. Up 2 over 1. Up 2 over 1. I can do that a number of times. I can also go the other way. I could go down 2. So negative 2 over negative 1 is the same. So that would tell me to go down, and then I go left. And so down 2 spaces over 1 to the left. You can do that a number of times as well. Well, from there we go ahead and draw a line through those points the best we can. And let's take a look at the next one. So this next line is similar in that the slope is the same, but the y-intercept is different. So here's the y-intercept. I start 1 space up on the y-axis, but I use the same slope. Remember, the slope here is 2 to 1 again. And so what that means is from that point I'm going up 2 over 1. Up 2 over 1. Notice that I never get any closer to this other blue line here. I get close as I go down, but then I got to go to the left, and I always stay the same distance apart. And that's the concept of parallel lines, is that they are always the same distance apart from one another. They'll just never touch. Well, parallel lines don't touch. What makes them not touch? Well, hopefully you saw that the slopes were exactly the same. And that's the key with parallel lines, is that here our slope is 2 to 1. Here it's 2 to 1. That's what is the same with parallel lines. And we're going to use that concept. So let's write that down. That is the big important concept that we must remember. Parallel lines have equal slope. So if we can find the slope of the line, then we'll know what slope to put into the point slope formula. So let's take a look at some examples here that we'll end up seeing. First one, well, this one's a great example, or nice problem for you, because we already can see the slope just by looking at the equation. What's the slope of this line? Hopefully you figured out the slope is 1/2, and I know that's the slope because y is by itself. It's in that form. Remember, the form goes y equals mx plus b. When y is by itself, our slope is the number that's being multiplied by x. So that's my slope. Now all we have to do is substitute the numbers into our point slope formula. We've used this quite a bit the last few days. And so we're just going to take our x value, that goes in for x1, the y value goes in place of y1, and the slope in for n. And we do that substitution. So we go ahead and rewrite our problem. We've got y, and then minus negative 3 equals the slope 1/2 times by x minus 4. And so whenever we see one of those minus negatives, we can change that right away to plus positive, and then distribute that 1/2 over that subtraction. So let's see what we've got now. We've got a y plus 3 equals 1/2 x minus, now, half of 2, or half of 4. Half of 4. Well, if I write that out, 1/2 times by 4 over 1, you see that 2 goes into 4 2 times. I multiply across, I get 2. So there's only one more step here, and that is to move this 3 over to the other side by doing an opposite operation. So I'm going to take it away from both sides, and we'll have our answer in the slope-intercept form. Y equals 1/2 x minus 5. There it is. Same sign, so I added. Well, here's another situation. This one's a little different, though, because we don't have y quite by itself. So we need to do some work to figure out what that slope of this line is. First step, if y is not by itself, get it by itself. Do an opposite operation to get y isolated on one side of the equal sign. So now we have y equals negative x plus 1. All I need to get from this equation is the slope. So looking at the slope, what's that number between the minus sign and the x? Well, hopefully it said negative 1. And so that is the slope, negative 1. That's the slope I'm going to end up using. So now we're going to go ahead and use this point again, a point of 2, 3, into our point-slope formula. So we'll rewrite that point-slope formula. Y minus y1 equals m times x minus x1. So 2 represents the x value, and then 3, well, that represents the y value. And then we have negative 1, that is our slope right there. So we can go ahead and substitute and see what we need to do from there. Y minus 3 equals negative 1 times by x minus 2. So we use that distributive property, multiply that negative 1 over the x and the negative 2, and see what's left over. Let's go ahead and bring down that y minus 3. This now equals negative x plus 2. Plus because the negative times the negative made a positive. Well, just one more step here and we'll be done. All we have to do is move this 3 back to the other side. So that's a minus 3, so I'm going to add 3 back to the other side. And now I've got my equation where y is all by itself. So we can rewrite this as y equals negative x plus 5. So there it is, the slope-intercept form. That line that we just wrote down is parallel to the first one that we have, but passes through the point that's given, 2, 3. Well, this next problem is even tougher than the last. It requires 2 steps to find the slope. We first need to subtract that 3x from both sides. So that's my first step. I'll rewrite what we've got. Still have that 4 out in front of y. We'll clear that in the next step. So we rewrite the negative 3x, the positive 8. And now we can get rid of that coefficient of the y term, which is divide by 4. Now you got to divide all numbers there by 4. So what's left over? Well, let's see. We've got this y equals negative 3/4 x plus 2. I divided 4 into each of the terms. If it didn't go in, I just left as a fraction. If it went in, I did the division. All we need is this number right here, though. That's it. That is our slope. So slope equals negative 3/4. We're going to use that slope and the point that's given to us, and we're going to put it in that point-slope formula. Remember, it goes y minus y1 equals the slope times x minus x1. So here is my x value. I'm going to put that in for x1. Here's my y value. That goes all the way over here for y1. And here's the slope. That goes in for m. So let's go ahead and rewrite our equation. We've got ourselves a y. And then it's a minus negative 2 equals the slope, negative 3/4 times by x minus 4. So whenever I see that minus negative, right away I go ahead and I change that to a plus positive. And then I distribute that negative 3/4 over that subtraction. So what's left over? Well, we've got a y plus 2 equals negative 3/4 x. And this is going to be a positive because the two negatives will cancel out. So off to the side, I'll write out negative 3/4 times by negative 4. The two negatives cancel out, but you'll notice these 4's cancel out as well, leaving me just with 3. So negative 1 times negative 3 makes positive 3. Now, just one more step to get y by itself, and that is to isolate the variable. So that's a plus 2, so I'm going to just take 2 away from both sides. And then I'm done. Got y by itself. So we can rewrite this as y equals, and then we can write negative 3/4 x plus 1. I had to subtract because they were opposite in sign. Well, those are some of the problems. There's a little bit of review with numbers 60, 64, 66, and 68. Part 2 will cover that.